Liila Torabi has a PhD from Simon Fraser University, and she is currently the Senior Product Manager for ISAC a robotics and AI simulation platform powered by NVIDIA Omniverse. And as you all know, ISAC provides researchers with the various tools to create robust, physically accurate simulations and synthetic data sets. And so we are very much looking forward to her talk. Liila, take it away.
Good morning, everyone. Thanks, Angela, Adam, and team for organizing this. I think it's about time to talk more about simulation, right? Yeah, my name is Liila, and I'm coming from NVIDIA. Today, we're going to talk about NVIDIA ISAC, which is a platform for developing and training for smarter robots. So I guess we all feel that smarter robots is getting closer and closer, like having the robots doing things autonomously. It's getting closer to become like a common practice. And that's because many things has happened, right? We have developed better hardwares, better softwares, better sensors. We have the AI has become more streamlined. So the time is getting closer to have autonomy, closer to the robotics. But the path would not be easy, right? There's going to be a lot of development. There's going to be a lot of testing, a lot of failing, a lot of designing and not being happy with it. So the simulation will be the key. The simulation will take us there to make it happen. Here's the very overview of ISAC. And in order to introduce ISAC, we have to start with Omniverse. The Omniverse is a platform, is a simulation platform that NVIDIA has built. And there are many applications on top of it, and ISAC is just one of those. And what Omniverse provides is the core technology for simulation. The physics is a big part of it, right? To simulate physics correctly. And then you would have the RTX for realistic rendering. These are the two core technologies. But other than that, there's a nucleus, which is like a data center at the heart of Omniverse. And the nucleus is not a data center, a data center is just the connecting all these pieces together, right? Every application would be a client to nucleus, and every connector will be connected to the nucleus. So I'm going to talk about this more, but the idea is that there's a lot of 3D tools out there, and you want to be connected to it. You have a CAD model, you're working with Unreal, so there's a lot of tools out there, and you want to be connected to those and bring them in. Also, you would have different applications that you want to work with each other. So it's like this in the middle of the heart of it, and all these applications can see the same 3D format and work on it in a different ways at the same time. The format of any file in Omniverse is USD. So anything that enters the Omniverse line will be in USD. And on top of this core technology, there has been many tools built on Omniverse. So like you would see the UI, the replicator, the OmniGraph, which I'm going to talk about. Then on top of this, you would see the ISAC, so what the toolset that we have created. Basically, as you see, all these blocks basically introduce an extension. Everything is super modular. You can enable or disable one or two. From the connectivity point of view, we do have a URDF importer. We have a JCF importer. You can bring on your SDF from Gazebo. So we make it easy to bring your files in if you want to try things in ISAC. Then we built on top of the core technology coming from Omniverse, meaning, for example, the sensor simulation is using the RTX for rendering, or for LiDAR simulation, or for radar simulation. And then we do present a set of robots and environments coming out just to play with it, but you would definitely more than welcome to bring other models from outside. We do have a ROS and ROS2 bridges, so you can easily develop your ROS stacks with ISAC. And then what we have done is, because everything in Omniverse is USD, and USD is not a language for roboticists. So we have built the ISAC core API on top of it, so we can abstract everything, all the USD from the robotics people, and you can just like focus on what is important for robotics. So it's like basically the robots, the tasks, the world, and so that's the abstraction layer. But the ISAC core API is just like abstracting for like making development of the robots in a classic way. On top of that, there are other abstraction layers for the AI part of things. So we have the ISAC Gym there, but we have the Tensor API now, so you can apply controls to thousands of the robots at the same time in optimized way. We have a new ISAC Cortex, which is a tool for programming behaviors, and we have Isaac replicators. So like it depends on what you're doing, you can pick the abstraction layer that you want to work with. And of course, all of the synthetic data coming out, you can connect it to the towel for training. So now the question will come, okay, talking about the development and training in Isaac Sim, what can I do there, right? For example, how can I get my robot for a spin in Isaac Sim? Or how can I connect it to my ROS software stack? And on top of that, the topic of today's workshop is how can I add AI to my workflow? Because the main thing is, yeah, we all have simulators that we can do, like move it around and simulate some sensors, but we need the AI to get to the next level, right? So there's different ways that you can add AI to your workflow in Isaac Sim. So I think these videos, you have read some of them. At the very top is just the test driving, then that's like a ROS, that's like the bottom ones are mostly the demos that we have. I'm going to talk about them more at the end, probably. So let's start with how you can go for a spin with Isaac Sim. We do have we have a couple of tutorials that gets you started with the Hello World, and all of that is because of Isaac, to have the Isaac core, right? So at the very beginning, we have like a very small UI, like let's say examples. The Hello World is just add a cube to the world, like that easy. And the good part about this extension, if you look at the very top left, you would see if there's a small icon. As soon as you click on that, you can see the Python code that is corresponding to that example. So it's easy to see, okay, if this is a Python code, I'm going to change a line and see how things work. And again, you could see that the whole example would be few lines because of all the abstraction that happened. We don't need to care about the USDs there. Right after that, you want to add a robot there, right? So it's another extension that you can see it. Okay, how can I see it? It's just like 3 buttons. There's nothing fancy there. It's just add a world, create a world, add a robot, and move it around. And then again, once you click it, it will take you to the Python code, and you can play around with the Python code and see how things work. Right after that, okay, now I want to add a controller to it, right? So I would just move around, take it for, I don't know, move forward, backward, go circles. So again, you can add a control. These are like just the very basic ones, just so you can be more familiar with the Isaac core and how like this API is going to make your life easier. And right after that is going to be that you want to make it more complicated and add a task to your robot, right? You have a manipulator and you want to do a pick and place sort of task. So again, all of these are extension. It has like a Python script to it, and you can play around with those Python codes. So this is just to get started, and with the robots are in there. But of course, you're not going to stick to the robots that we provide, as maybe 10 or something. And the environment that we provide. So you want to move on to your own. This is a table that comes from the Omniverse, like and shows different ways or different tools that are connected to Omniverse. So the chances are that most common, let's say, tool sets are covered here. So if you have a 3D model, if any of these formats, you can bring it in on like Omniverse and Isaac Sim. Some of them are more complex, like let's say, developed, like Unreal Connector, which is two-way, right? You can bring up your environment from Unreal to Isaac Sim or move it backwards. Some of them are just one way. But anyhow, it means that if you find a 3D model out there and you like it, it's most likely you can bring it in Isaac Sim easily, right? So that's the idea here. And on top of that, Isaac Sim has provided its own sort of connectors and porters to make it easy. So you can bring the URDF, you can bring in like a Majorca format, you can have, if you have a CAD model on Shape, you can bring the CAD model in. If you're working with Gazebo and you have an SDF, you can bring that in. Or if you're doing some training and you want some models from Shape, then you can bring it in. Or you can write your own connector. So that's like, even these are not going to limit you. You can write your own connector. We already are working with many big industries that they will build their connector to Isaac Sim. So you can write your own connector and bring a data set into like Isaac Sim. Now let's get more details of what are the ways that you can develop an Isaac Sim, right? At the very top is a GUI. I know that we are like roboticists are not really GUI people, but you want to start with GUI at the beginning. before getting into Python or ROS, you just want to move around, see how can I add things to my scene or play with it. So the GUI is something that comes with the Omniverse. Isaacson has added a couple of GUIs to more robotic specifics, but they're usually very visual, intuitive, like make it easy to inspect your robot, just move the joints or inspect the physics of it. So the GUI can help you on that side. Are you just, as let's say you have a manipulator, you want to throw it at the scene and just move the joints and see how things work. That's where the GUI be your good friend. The second one is the extension, right? The one that I showed, the hello world and all that. And that means that you would have like a Python script that has a GUI like connected to it, and just by clicking is more events driven, right? You would say, okay, click, load, it clicks the robot in, and then you say move, or you say, you give it a task. So it's like a more event driven. The good thing about the extensions is that they are hot reloading, meaning that once you change a line in your Python code, you can like immediately see the change in the simulation. You don't have to restart the simulation to see the changes there, right? So that's the extension part, and you can build your own, or you can get the one of the hello world, change the line and make it your own. So there's a lot of ways to write your own extension. The other way of working is the standalone Python, and this is mostly when you want to be in charge of taking the simulator. Mostly happens when you're doing reinforcement learning or you're doing training for creating synthetic data, and that's where you really want to do stepping the rendering. You want to step the physics. You're not like a GUI thing. You just want to run it yourself. So that's another way of doing it, and we have a couple of examples to show you how you can do that. And we do support Jupyter Notebook. So if you are looking to like your development through the Python code, there are different ways of playing with your robot, like either extension or standalone, or like through Jupyter Notebook. The second thing I want to talk about is OmniGraph, and that is because OmniGraph is becoming a core thing in a coming release that is going to be in the next week. And that I'm going to show this video to you. OmniGraph is a compute graph that comes with OmniGraph, with Omniverse, and makes the programming way more modular and easy, meaning that you would have modules with inputs and outputs and a function assigned to it. So let's say, for example, if you have a function that it just creates synthetic data for you, once you want to send it to ROS or once you want to send it to ROS2, all you have to do is just like basically connect it to a ROS publisher or ROS2 publisher. So makes programming way easier. If you check our like a new release that is coming soon, you will see all of our ROS examples are now OmniGraphs, because it makes the life way more easier. Here you would see, for example, how things work every node will have like sort of a similar to JSON file for it defining the inputs and outputs, and you would like sort of the function would be a Python file, and then all of this will like sort of show like in a compute graph. They're already like some ready to use OmniGraph nodes for you, but you can like make your own custom OmniGraph node. So this is an example that shows how you can make it. This is like just going through the lines of how you would do it, but this basically just controlling a robot to like an OmniGraph node. Let's see if I can take this a bit forward. Yeah, so this is the node that you can see, and that's like for controlling that robot. So this is the new way of programming and makes it easier. It is like every node, if you click on it, you can go to the Python code inside of it. So these are all different ways that you can do development inside Isaacson. And now it comes to ROS. Of course, we do have a ROS and ROS2 connectors, right? So, and we do have a couple of examples for the very common, let's say, practices, which is manipulation and navigation. So you can see that you can connect your manipulator to move it and move stuff from the move it and check it out with Isaacson or vice versa. So the bottom is the move it, the top is Isaacson, or the other way around. So all the messages are there. You can just try the manipulation in Isaacson. We also do support navigation, of course. So you can do multi-robot navigation. All the messages are there. So we have a couple of examples for navigation and manipulation. But again, you can write your own custom messages for any ROS application. And with the new release, we would have like in a quadruped example as well. So you would have a quadruped controller in Isaacson, so you can check that as well. And back to like the connectivity, if you're working with Gazebo right now, we did a collaboration with Open Robotics folks, and you can now convert your SDF file to USD, or the other way around. You see a robot in Isaacson, you like it, you can take it to a Gazebo and try it there. So that you have the basic file conversion there. You can also do this at runtime, right? Meaning that you can run your Gazebo and then connect it to Isaacson and move it at the same time, right? So you see which one you think is more reliable for your experiment. Sometimes it's this one, sometimes the other one, or the other way around, right? So you can start your simulation either from Isaacson and connect it to Gazebo, or start with Gazebo and connect it to Isaacson. Also, we have a hybrid, right? Let's say you want to do the physics in Gazebo and you want to do the rendering in Isaacson. So you can find all of the tutorials in the Gazebo GitHub. It's like open source. You can check it out. You can contribute to it, of course. But the idea is that if you're using Gazebo right now, there's like an easy way to get into Isaacson. Okay, just checking the time here. Okay. Now we want to talk about the AI part of things. The first part of the AI we want to talk about is the synthetic data generation, right? We need a lot of data for a robot for training. And then we have to find a way to create these in a simulator, because there are different reasons why we cannot have them in the real world, right? Isaac Replicator is a tool for creating data, synthetic data for your training. You can do many things to it. One of them is scene creation, like a scenario creation. Let's say you want to have a robot and then you want to simulate the edge cases. A person is walking behind the robot, what happens? If somebody jumps somewhere, or like a forklift is coming, or it's a bicycle just passed. So you want to simulate all of those edge cases in a simulator before you have it in the real world. And then you have the domain randomization, right? We want to, for training, we need a lot of data. For having a lot of data, we need to randomize what we have. And then at the end, once you have all of the data, you need to annotate it based on what ground truth you need. And then you want to write it and take it for data generation. So we do have TAL at NVIDIA as well. You can connect it to TAL. Once you write it in a file format of Kitty or Coco, and then you can use that for training. So I'm going to give you one example. So there are a couple of workflows in Isaacson for training. One of them is once you want to do, let's train a specific object. You want to train your robot to detect a forklift or detect any object. There are a couple of workflows there to do that. You can randomize it, do like all sort of crazy stuff with the camera, with the lighting, with the materials, to create all sort of that data for your training. So this is mostly for when you want to train your network to detect the specific objects. We also do have a similar one when you want to get the pose of an object, which is really important once you have like a sort of a pick and place and you have a manipulator in place. The other way of doing randomization is once you want to create different scenes and scenarios, and it's very important when you want to do, let's say, CI/CD. You have a menu. Let's say you have a mobile base. You want to run it in different environments and see when it hits the wall or hits the box or something. So you can procedurally create many different scenarios there. Here we have like sort of a Lego kit for a warehouse, and we procedurally generate lots of warehouses with it, so you can run your robot inside it and see when does it hit something, or it doesn't. The ground truth that we provide is, of course, the main ones that the RGB, the depth, the segmentation, semantic instances. We do have the point cloud. We have the bounding boxes, we do have the pose, we have like normal. So there are a lot of ground truth annotation is available depending on your application. And of course, you can write this, like Isaacson comes with a couple of writers like Kitty, but you can write your own writer as well at the end if you need a specific format for your training. And the other part, a good part of it is NVIDIA has like a toolkit, it's named TAO, that they're like sort of a pre-trained model optimized, and you can use that to just not start from scratch and connect your models to it and just bootstrap your training from there. Okay, so this is the synthetic data, which is a part of the AI added. The next part is about Isaac Gym. Some of you might have heard about Isaac Gym if you're into reinforcement learning. For a while, it has been like a standalone application, which has been used for reinforcement learning. And for a while, we have promised that these two will like just be unified. So you guys are not confused what is Isaac Sim and what is Isaac Gym. Hopefully that they have become, right? So now Isaac Gym is part of Isaac Sim. It has been unified. And you could do reinforcement learning inside Isaac Sim. The way it works that we have implemented the Tensor API, which previously was only available in Isaac Gym, and that means that you can pass the control to thousands of the robots in a tensor way, optimized way, and do the reinforcement learning. So we have implemented the Tensor API for reinforcement learning, and you can use the Tensor API basically for any robotics application. It's not limited for reinforcement learning. Let's say you have thousands of this, like the drones that Angular has, right? So the Tensor API will become very handy there. And then we have like the Gym API on top of it in order to connect to your own RL, let's say library. We will come up with an example to show how you, if you have, let's say, your RL library outside of Isaac Sim, how to connect it to Isaac Sim. And that is to just show you, if you have an RL library anywhere, how to connect it to Isaac Sim and do the training there, right? So the library is not going to live in Isaac Sim. The goal is to show how to use Isaac Sim to do reinforcement learning there. So the example that we will have here is both on the training side and the inference side. In the middle, you can see the famous animal that's you see the show everywhere. It has been trained in the standalone gym. We will do the inference in Isaac Sim, but you can do the training of your humanoid, the shadow hand, everything in Isaac Sim. Now these examples will come with Isaac Sim in the coming days. Okay, so this was the Isaac Gym. The next part, the next feature that it comes is the Isaac Cortex. Isaac Cortex is the new feature that is coming with the new release of Isaac Sim, and that's basically for a programming toolkit for behavioral. So the idea is, let's say, a very simple block stacking example. If in the old days, what you have a couple of blocks, you have a robot there, right? And it just blocks them on top of each other. So the decision tree should be very simple. But once you have the human in the loop, right, things are different. Or if the environment is dynamic, because things are changing. You put a block on the other one, but somebody just blows it out, or somebody just messes around with the robot and picks the blocks and put it somewhere else. The robot has to be interactive with all of those changes, right? So the decision tree becomes more complex here. And the key here would be the perception, right? Now you need to know what is happening outside and be reactive to it. So you have to be more aware of what's happening around you. Cortex is just the very beginning of its life, but you would see the basic example like coming in this release, and that is like in the middle you do have the decision tree. Okay, make it go through the decision tree, and I'm going to wrap it up here very soon. So if I got you guys interested in Isaac Sim with all of this talk, and you're now thinking where you can get it, there's two ways to run Isaac Sim. You can run it on the cloud. Either way, you go to NVIDIA developers and you download the container. Or if you want to run it locally, all you got to do is you go to the Omniverse, right? And you download the launcher. This is the launcher of the Omniverse. It has many applications on top of it. The Isaac Sim is the one in the middle, right? So, but there are like all these applications. So all you got to do after you install the launcher, you would you go to the launcher and pick Isaac Sim and click install. That's all about it to install it. So if you're asking when the Isaac Sim is out, our previous release is from last year, but our next release, which includes all these cool features from the Gym and Cortex and synthetic data, is coming the first week of June. So hopefully you guys will try it out. I don't think I do have a cool video, but I don't think we have a time for it. So let me know if we do. Do we?
You can start it, yeah.
Okay.
Yeah.
Successful development, training, and testing of complex robots for real-world applications depend on high fidelity simulation and accurate physics. Built on NVIDIA's Omniverse platform, Isaac Sim combines immersive, physically accurate, photo photorealistic environments with complex virtual robots. Let's look at 3 very different AI-based robots being developed by our partners using ISAC-SIM. Fraunhofer IML, a technology leader in logistics, uses NVIDIA ISAC-SIM for the virtual development of Lex, a highly dynamic indoor-outdoor autonomous mobile robot, or AMR. After importing over 5,400 parts from CAD and reading with Omniverse physics, the virtual robot moves just as steadily in simulation as it does in the real world. This not only accelerates virtual development, but also enables scaling to larger scenarios. Next, Festo, well known for industrial automation, uses ISAC-SIM to develop intelligent skills for collaborative robots or cobots requiring keen awareness of their environment, human partners, and tasks. Festo uses Cortex, an ISAC-SIM tool that dramatically simplifies programming cobot skills. For perception, AI models used in this task were trained using only synthetic data generated by ISAC Replicator. Finally, there's Animesh, a robot dog developed by a leading robotics research group from ETH, CERT, and Swiss Mile. Using end-to-end GPU-accelerated reinforcement learning, Animesh, whose feet will replace the wheels, learned to walk over urban terrain within minutes rather than weeks using NVIDIA's ISAC Gym training tool. Collision policy was verified in ISAC-SIM and employed on a real Animesh. This is a compelling demonstration of simulator training for real-world deployment. From training perception policies to hardware in, ISAC-SIM is the tool to build AI-based robots that are born in simulation to work and play in the real world.
Thank you all, and apologize for going over the time.